like a Hellcat.
Hey guys, so welcome back sa ating YouTube channel. So in this video, ito yung continuation ng ating Lagrange theorem. So dito natin pag-uusapan yung mga about order na ng group. So since na-discuss ko na si Lagrange, tuloy naman na natin yung mga order. So actually, ang idea dito is pinaka main topic natin is dito is the index of H in G. Okay, so paano natin kunin yung index? Pero ito muna tayo pag-usapan. So let's have the corollary. So again, these are the consequences of theorem of Lagrange. Consequences ng theorem of Lagrange. Okay, so we have corollary 7.1.3.1. So kung napansin mo 7.1.3.1, so meaning part siya ni or nanggaling lang siya kay Lagrange theorem. So 7.1.3 kasi si Lagrange kung naalala nyo. Now, if G is a group and A is an element of G, then the order of A divides the order of G. So paano siya i-prove? Actually, napaka-simple at napaka-basic lang niya. So ito yung proof. Okay, so note or recall that the order of A is equal to the order of the cyclic subgroup generated by A. Tama. So, kung naalala nyo, tama yan. So, next is since the cyclic subgroup generated by A is a subgroup of G, and we all know that. Okay, then by Lagrange theorem, the order of A divides the order of G. Okay? So, the order of the cyclic subgroup generated by A divides the order of G. Therefore, or this implies that the order of A divides the order of G. So, this is done. Okay? So, napakasimple. Yeah. So, now, let's have 7.1.3.2. Actually, obvious siya, no? Tama naman yan. So, yung order of A kasi, so for every element A, meron tayong cyclic subgroup generated by that element A. Okay? So, alam natin na cyclic subgroup generated by A, so alam natin na hindi lagi distinct. Possible na equal siya kay B, yung cyclic subgroup generated by B. But, they have the same order. Tapos, may idea tayo na pag siya ay subgroup, sabi nga na, kung ikaw ay subgroup, automatic, dinidivides mo lang yung order ng G. Okay? Kasi nga subgroup eh. Okay, so may theorem din tayo actually na-discuss doon sa cyclic pa lang tayo. Okay, so now let's have corollary 7.1.3.2. So if the order of G is P is a prime, then G is cyclic. So ito naman yung medyo kakaiba, no? So paano natin ipo-prove? So kaya alam niyo ba, so I think alam niyo man kung ano yung prime. So prime is, sample is 2, 3, 5, 7. So prime number is a number in which the only factor is 1 in itself. So yung pagiging prime, ang factor ko lang is 1, tapos yung sarili ko. So yun yung pagiging prime order. So ngayon, sabi nga lang dito, ang sabi ng corollary na to, kung ang order ng G is in prime order, therefore ikaw ay cyclic. Therefore si G is cyclic. Okay, so let the order of G be equal to prime or P. Okay, so, no? So, the order of G is greater than 1. Kasi nga, hindi naman prime yung 1. Alam natin na hindi siya prime. So, again, let the order of G equal to P, which is prime. So, the order of G is greater than 1. So, now, let tayo ng A, which is not equal to E, which is element of G. Again, naglet ako ng A na hindi element E, na kung saan element naman siya ni G. So, ibig sabihin, hindi siya yung identity element. Okay? So, by distinction or by assumption, by previous corollary, we all know, so, the cyclic subgroup generated by A is a subgroup of G. Tama? And we all know that the order of the cyclic subgroup generated by A is greater than 1. Sir, bakit? Kasi nga, since ako ay subgroup ni G, tapos ako ay hindi identity element, ano lang yung order ko? Yung iba, other than 1, ano yun? Since ako ay greater than 1, si G greater than 1, so ano masasabi mo sa order ng G? Saka order ng cyclic subgroup generated by A. Then, lagay ko na lang no, then, the order of A is equal to the order of G. So, again, imagine nyo yung nangyari ha. So, let G be in prime order. So, alam natin na siya ay greater than 1. Okay? Now, if we let A not equal to E, which is element of G, so, we all know that the subgroup generated by A, or the cyclic subgroup generated by A is a subgroup of G. Okay? So, alam natin na siya ay subgroup of G. Now, alam din natin na yung order ng A is greater than 1. Why? Kasi hindi siya identity element. Okay? Yung order ng the cyclic subgroup generated by A is greater than 1. Ngayon, ano na lang masabi mo? Since siya ay subgroup ng G, ano ba yung possible divisor ng prime? Ang possible divisor ng prime is P and 1 and P. Okay? Since the possible divisor, so lagay ko na lang, no, since the possible divisors of P is 1 and P. Okay, so nilagay ko na lang dyan, 1 and P. In which, ano na ibig sabihin? Ano na nakikita yung order ng G? Therefore, the order of G, or the order of cyclic subgroup generated by A is equal to G. So, yan yung pinaka-reason. Now, kung ganun yung nangyari, ano man sabi nyo? Ano masasabi mo kay A? Ano ba sabi ni A? Sir, alam natin na kung si A, kung si A is equal doon, ibig sabihin siya lang mismo si G. So, ibig sabihin may generator doon. Or actually, siya ay generator kasi kaya kong kunin lahat ng element or laman ko lahat ng element mo eh. Again, laman ko kasi lahat ng element mo. Okay, G, o si A. Ako si group A, ako si subgroup A, subgroup cyclic subgroup generated by A. Lahat ng element mo ay kaya ko, ay meron ako. So, meaning, ako ay generator mo. So, therefore, G is cyclic. Therefore, G is cyclic. Okay, so napaka-basic niya, no? So, pag nakita mo agad na yung order ng G is prime, so, automatic siya ay cyclic sa kahit anong group. Okay, so siyempre except basta prime order. So baka sabihin mo, sir, yung identity element o yung group ng identity element o yung trivial subgroup siya ay cyclic. No. Cyclic siya pero hindi siya consider actually cyclic yun. Kasi nga generator na rin sarili niya eh. Okay, so tama pala no. So namali ko yung sarili ko. So sorry about that. Okay, so now kasi tayo dito 7.1.3.3. So if G is a finite group, then for every A element of G, we have A raised to the order of A is equal to E. So ang ganda ng idea na yan, no? So kunyari nakita mo si kunyari na lang yung order ng ating basta lang mamaya na lang pag nakita nyo. Basta yung order ng isang element. Kunyari, yung order ng isang element is 4. Kunyari lang A order niya is 4. Pag si A na-raise ko sa 4, equal lang siya sa A. Kunyari, A asterisk A asterisk A asterisk A equal siya sa A. So, again, na lang. No? Kunyari, assume, for example, ang order ng A, sorry about that. So, kunyari, ang order ng A is 4. So, ang ibig sabihin niya, yung A raised to 4 is equal to A asterisk A, asterisk A, asterisk A, equal lang yan sa A. Na yun yung sinasabi. So, basta order niya. Yun yung sinasabi ng corollary na to. Okay, so, paano naman siya ipoprove? So, I think napakadali na lang siya, no? So, ito yung proof. Okay, so by corollary, number ng corollary yun. So, by corollary 7.1.3, so itong nauna na to. By corollary 7.1.3.1, okay, we all know that the order of A, okay, we all know that the order of G, the order of A divides the order of G. Okay, and this implies that the order of G is equal to K times the order of A, or cardinality of A na yan. So, for some K na lang. Okay, so by definition of divisibility. Okay, so thus we have this. So, A raised sa order of G, which is equal sa A raised sa K times the order of A. Okay? Is just equal sa, ano to? This is just equal sa A, order of A, tapos naka-array sa K. So, again, ang ginawa ko, pinaghiwalay ko yan. So, yung K nilabas ko. So, A raised to order of A, raised sa K. Ngayon, ano yung A raised to order of A? Ang A raised to order of A is equal to E. Okay, so which is equal lang sa E raised sa K or simply E. So, therefore, this is done. Okay, so, which is, ginamit ko yung assumption. Ayan. So, again, ito yung mga consequences ni theorem of Lagrange. So, part din talaga siya or na-discover siya dahil sa theorem na Lagrange. So, napakalaking tulong yan dito sa atin, lalo na pag pinag-uusapan natin is order. Okay, so now let us proceed dito sa ating next topic. So, ang highlight talaga ng topic natin for today is the index. So, let H be a subgroup of G. So, you know, let H be a subgroup of G. Then, the number of distinct left, okay, or right coset of H in G is called the index of H in G. Again, the index of H in G is denoted by G nakalimutan ko tawag, G colon H is equal to cardinality of G over cardinality of H. So, para malaman mo yung index niya, kunin lang natin yan. Divide lang natin yung order ng G sa order of H. Ganun lang kasimple. Okay, so dito tayo proceed. So, example, let G be equal to the set containing Z, plus, and H is equal to 3Z. So, we all know na infinite order tong dalawa. No, ito yung unang tanong. Sir, infinite order sila. Paano yun, sir? Okay? So, kung ganon, hindi applicable. Hindi applicable tong definition na to. Kasi hindi mo pwedeng i-define yung infinite sa infinite. Sir, mas marami naman to dun eh. So, parang infinity divided by something na 1/3 infinity, that is simply 3. Hindi ganon. Okay, so since alam natin na yung left coset, so again, hindi applicable yung definition since the number of left of distinct or right coset, distinct left or right coset is 3. Okay, so the index of H in G is just equal to 3. So again, pag hindi mo kayang i-divide, totally pag infinite number, so ang gagawin mo lang is simply, parang, gagawin na lang natin is something na, okay, kunin mo na lang left and right coset. Actually, kahit left coset lang, kasi alam mo naman, equal lang din naman yun sa right coset. Okay, so kunin mo lang yung ilan yung left coset niya, then ayun na yung kanyang index. Okay, so tapos na siya agad. Okay, so proceed tayo dito. So ito actually pwede to. So if G is equal to the set containing 1, -1i, -i, so ito yung comma, asterisk, or multiplication, and H is equal to the subgroup 1 and -1. So the index of H in G is just equal sa order of G over the order of H, which is equal lang sa 4 divided by 2, which is equal sa 2. So meaning may 2 coset dyan. Which is tama naman. Bakit? Kasi dito pa lang, no, sa H pa lang, so actually may theorem nga tayo, no, sabi nga nila na yung AH is equal, yung cardinality ng AH is equal to H. So, para malaman mo rin index, isa rin sa pwede natin gawin is the order of the index is just equal sa the order ng H. So, pwede natin sabihin to actually. Yung index of H in G is just equal sa the order of H. Kung alam yung order ng H. Pero hindi nga lagi applicable yun. So, tandaan yan. Okay, so na-proceed pa tayo. So, medyo mabilis ang video na to. Buti naman. Okay, so, theorem 7.1.4. So, extend natin yung pagiging index niya, no? So, if K is a subgroup of H and a subgroup of G. So, again, si K subgroup ni H. Si H subgroup ni G. Obviously, si K subgroup din ni G yan by transitivity. Okay? And suppose that the index of H in G and the index of K in H are both finite. Again, the index of H in G, the index of K in H are both finite. So, meaning nag-e-exist. Okay, at the same time, hindi sila infinity. So, then, the index of K in G is just equal the product of the index of H in G times the product, times the product of the index of H in G and the index of K in H. Okay, so, kung gusto mo makuha yung index ng K sa G, provided na ganyan yung condition, ibig sabihin, ayan siya. Okay, so yan yung gagawin natin. So, paano yan? So, yun, napapaisip na naman tayo paano yan. Okay, now, suppose that K is a subgroup of H and a subgroup of G, and the order of K is 42, and the order of G is 420. What are the possible orders of H? Okay, no? So, sa gitna talaga yung pinag-uusapan dito. Okay, so, derive nga natin muna yung formula, no? So, sabi by theorem 7.4, yung index ng G to K is just equal sa index ng H sa G multiply by the index of K, of K in H. Okay, so pag in-apply natin yung isang theorem, this ay definition, this is just the order of G over the order of H multiplied by the order of H over the order of K. Okay, so ngayon, yung index kasi hinahanap natin eh. Okay, so ang tanong, ano ang possible order ni H? Okay, simple actually cancel lang to. No, cancel. So ibig sabihin the order of G is okay, o yung index ng G to K, yung index ng G to K is something na 420 over 42. So that is 10. Tama. So again, ibig sabihin na nito, the index of K is just equal sa 420 divided by, so again, multiplication na yan so cancel tong H, cancel yung order of H, so 420 divided by 42, this is 10. Okay, so meron tayong 10, so index ng K in G is 10. Pero ang tanong, what are the possible order of H? So meron tayong index ng K sa 10. Okay, so ano yung possible order ng H na yan? So yun yung ating katanungan. So paano ba natin siya kukunin? Okay, so again, this is 420, this is 42. So ano yung H na yan? Para makakuha tayo ng 10. Okay, so again, the index is 10. So I guess, gamitin natin tong equation na to. So we have the index of K in G is equal to the order of G over the order of H multiplied by the order of H over the order of K. Okay, so again, alam natin na ito ay 10. So aware ka na ito ay 10. Okay, so ano yung mga possible multiplier ni 10? Factor ni 10 rather. So sir, ang mga possible factor ni 10 sir. So combine buuin natin. Sir, pwede po 2 times 5. Another po 5 times 2. Tapos po 1 times 10. Tapos 10 times 1. Okay, so from that, bubuin natin yung mga possible order. Okay, so ano ibig sabihin nun? Una is, alam natin yung order ng G. Okay, so order ng G over H is equal to 2. So, para sa una. So, unang solution is something na, ito. Alam natin na yung order ng G over the order of H is equal to 2. Tapos yung isa, the order of H over the order of K is equal to 5. Okay, ayun yung una para sa 2 times 5. So, alam natin yung order of G, which is 420. So, this is 420. So, again na, this is 420 over order of H is equal to 2. Dito naman is H over 42 is equal to 5. And we all know ano yung order of H dito. The order of H dito is just 210. So, this is, sagot dito is 210. So, isa na yun. Dito naman, ano yung order of H? This is 210 also. This is 210 also. So, ayun, nakakuha tayo ng isang value. So, now, ulitin natin ulit dun sa pangalawa. Doon naman sa 5 times 2. So, again, ganun ulit. So, the order of G over the order of H is equal naman sa 5. Then, the order of H over the order of K is equal naman sa 2. So, alam natin, order of G is 420. Now, this is 420 over order of H is equal to 5. Dito naman is order of H over order of K is 42 is equal to 2. So, again, 42 divided by 20. Ano yung magiging sagot dyan? So, yun, tinago ko pa yung calcio ko. Gagamitin ko rin pala. 420 divided by 5, that is simply 84. Tama ba? So, tama 84. So, ito ay 84. This is 84 para dito. Dito naman, 2 times 42 is 84. Okay, so 84. Okay, so next is, syempre yung number 2, suppose that G is finite, prove that the cardinality of G is greater than 1 and has no proper non-trivial subgroup. Prove that the order of G is P where P is prime. Okay, so I think I leave it as assignment. Hindi ko na siya ipoprove dyan. Kasi kailangan kidugtong to eh. Okay, so now proceed tayo sa sunod. So this is yung 110 naman. So the order of G over the order of H is equal to 1. The order of H over the order of K is equal to 10. So note that this is 420 over order of H is equal to 1. So obviously 420 sagot dito. Okay, so now ulit. So next is order of H over yung order ng K is 42 is equal to 10. So obviously this is 40, 20 din lagi. Okay, so napansin mo, tatlo na kuha natin order. So 210, 84, and 420. So lastly, 10 naman. The order of G over the order of H is equal to 10. The order of H over the order of K is equal to 1. So this is just 420 over the order of H is equal to 10. This is the order of H over 42 is equal to 1. So obviously this is just 420 divided by 10. This is 42. And this is also 42. Okay, so what are the possible order? The possible order are possible order of H are 42, 84, 210, and 420. Okay, so ito yung ating sagot. Okay, so for yung number 2, so let G be a finite group, so which is the order na is greater than 1 and has no proper non-trivial subgroup. So meaning wala siyang identity element. So hindi pasok dito yung pagiging identity element, tapos hindi pasok na equal yung G. Non-trivial. So yun nga yung identity element, yung subgroup niya na identity element. So hindi siya identity element rather. Okay, G is not equal to the set containing E. Now prove that the order of G is prime where P is prime. Okay, so ito medyo related dun sa ating corollary kanina. So I guess dun yung gagamitin natin dun. Pero I think kayo na yung mag-gather ko paano yung information na yung gagawin dyan. So kasi ito yung importante talaga. Okay, yung theorem 7.1.4. Okay, so yung parang upgraded version ng ating index. So again, hoping na may natutunan ka about index at the same time yung itong part na to. So kasama to sa inyong mga exam, something. So hoping na gets nyo. So next is yung ating topic talaga dito sa chapter, which is the normal subgroup. So this is a pre-introduction para sa susunod na group, which is the quotient and the factor group. So again, thank you for watching. Hoping na panoorin pa yung next video natin that is about normal subgroup. So thank you.